Okay, so going to move on to the next section here. So intro to series. So we've defined a sequence. The difference between a sequence and a series is a sequence is the part of the series. So a series is actually the sum of all the terms in the sequence. So here I have a finite sequence. And so the associated series with the sequence is going to be 1 plus 4 plus 9 plus 16 plus 25. So all I did was add all of the terms of the sequence together, which is exactly what a series is. But we don't want to have to write this out every single time. So what we're going to do is we're going to give a what's the word I'm looking for? We're going to come up with the function for this. So we have this thing called a summation. First, let's define a sub n. If you notice, each of these numbers, 1, 4, 9, 16, 25, those are perfect squares. And if we were to go in order, they're each n squared. So this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So if you're good at finding patterns, this section will be really easy for you. It takes some practice. I think it's pretty fun stuff. Okay, so here is my function. So I'm just going to write out the different parts. So this big guy right here, that is called a summation. So that is our summation symbol right there. We're going to have a place to start and a place to stop. This marker is about dead, but we'll make do. So this is going to be n equals something. And this is going to be our starting point. Quite out of frame. Barely see it. Okay, so there's our starting point. And then, let me see if I have another marker in here. It worked. Up top, this will be our stopping point. Now it's easy on this one to count it out. So we have 1, 2, 3, 4, 5 terms. So n equals 1. So we're starting with term 1. And we're stopping with term 5. So that's the way we write it out. And so this would be read the summation of my function, which is n squared. So that's where my a sub n goes, from 1 to 5. Okay, so what that is equal to is 1 plus 4 plus 9 plus 16 plus 25. I trust you know how to add some numbers together. This is equal to 55. But we don't want to have to write this out every single time. So it's important that we know how to write this summation out. So I'm going to write it a little bit cleaner down here, just so we have it. So we have summation n equals 1 to 5 of n squared equals 55. Okay, so that right there is our answer. We have a couple examples on the back I want to go over. And then we'll be finito. And that bled through. Hopefully you can see that okay. All right, so we're evaluating these. How do I get out of this? No. There we go. Okay, so the directions might say something like, get him out. Find the value of each series by hand. So when it says by hand, that means show your work. And there will be times where you need to show your work as proof. Oh, and of course, you can't see the directions. Zoom out a little bit. There we go. Okay. So we're going to run through when you're first getting started, the best way to do these is to kind of write out what is the sequence. So here I've got a sub n is equal to k, which actually it's going to be a sub k is equal to k. They can use whatever variable you want. Usually n and k are the ones that they use. And so the sequence k is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, and it doesn't tell us whether it's finite or not. It just gives us k. So that's it. However, we have to note that this goes from 1 to 6. So we're only going to do the first 6 terms. It's obvious on this one because it's just counting up by 1. So what we're going to do is we're going to add 1 plus 2 plus 3 plus 4 plus 5 plus 6. And if you're showing your work, you're showing all of that. All of that adds up to be 21. All right, let's do a second example. So for this one, I've got the summation of 5 from 1 to 8. So this is how the series goes. It goes 5 is the first term, 5 is the second term, 5 is the third term, 5 is the fourth term, 5 is the fifth term, and so on and so forth. And it keeps going up. It only wants the first 8 terms. So we're going to go ahead and add that to itself 5 times. So 5, 1, 2, 3, 4, 5, 6, 7, 8. And of course, you can use simple math to figure out that this is equal to 40. All right, so on ones like this, you really don't have to write it out. It's kind of silly to write out the sequence every single time because you kind of know how to do it. On problems like this, you especially don't want to turn my phone off. Want to write out the sequence because it ends up adding more work for you. But we'll note that the amount of terms that we have. So I'm looking for the terms from 0 to 4. So what I need to do on this is I need to plug 0 in for k in both the numerator and the denominator. So here's our first term, 0 over 0 plus 1. So this is term 0. Then we need to add term 1 by plugging 1 in. So we have 1 over 1 plus 1. Term 2, term 3, and term 4. So that's how we would write that out. Then we want to simplify, so we get 0 plus 1/2 plus 2/3 plus 3/4 plus 4/5. We'll use our handy dandy Desmos calculator so we don't have to tire ourselves adding this up. Oh wait, I added, dang it, wrong one. Okay, so we have 0, I'm just going to type it for kicks and giggles, 1/2 plus 2/3 plus 3/4 plus 4/5. And I have 1, 2, 3, 4, 5 terms. 0 to 4 is 5 numbers. And then, of course, we want to turn it into a fraction because we had fractions to begin with. And so, oh, that's kind of fancy. 163 over 60 is our final answer. And I'm using different color markers. 163 over 60. Easy as that. Okay. So sometimes it's going to say express each sum by using summation notation, and it'll write it out like this. So it's kind of basically you're working backwards. And this is kind of where you have to start using your brain a little bit more. You can see that we're adding 1 each time. And we go up to 37. Now, it's pretty obvious that 1 is our first term, 2 is our second term. And so if we were to plug in, it'd be just n. So here I'm going to have my summation symbol. I'm starting with something, I'm ending with something. And if we were to just say n, because it's going up by 1 each time, we're starting with 1 and we're ending at 37. That's it. Super easy. That's all we need to do. But I didn't add a harder example, but I'm going to do it right now because I feel like the more examples we do, the better. So we're just going to have our sum 2 plus 4 plus 6 plus 8 plus 10 plus, let's do 44 because that's fun. Oh, shoot. Plus dot 40. 40. Okay. Sorry, it's a little bit messy. This right here is an ellipse. Okay, so you can see that we're going up by 2 each time. So that means that our function is going to be 2n. So if 2n is equal to 2, our first number is n equals 1. And then if 2n is equal to 40, n is equal to 20. So that means if our function is 2n, which if we were to test our other values, we're going to do that in a second, we would have n equals 1 of 2, or I'm sorry, summation of 2n from n equals 1 to 20. If we were to test this out, which it's always good to, just to kind of check your work. Cool, dead marker. Then we end up with 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And then 2 times 20 is 40. So we know that it works because of that. So next up, we'll talk about arithmetic sequences. For now, we're done. Congratulations. Enjoy the rest of your day. Remember to log on if you have any questions on Google Classroom. I'll have a link to Google Meet. Later, Gators. How do I turn this off?